All right, so I to the first is I squared is -1. I cubed, we hadn't talked about I cubed, this would be new, but I cubed, we could think of that as I squared times I. Does that make sense? I squared times I would be I cubed, which would be, well, I squared is -1. So that part is -1. This part is just I. So that becomes -I. What about I to the fourth? How could we sort of rewrite or break up I to the fourth? I squared times I squared. But we know what I squared is. So what's I squared times I squared? 1, because -1 times -1.
I see.
What about I to the fifth? And watch where I put I to the fifth. We could rewrite I to the fifth as I to the fourth times I. Well, we could write it a bunch of different ways, but why would I pick to split it up with the I to the fourth? Because I to the fourth is 1, so that's going to make this easy. So I to the fifth is just I. What do you think I to the sixth is? I to the fourth times I squared. Again, we like using I to the fourth because it's 1. And then I squared is -1. So that's -1. What about I to the seventh? -I. Either you picked up on the pattern or you think, well, let's just do it this way. That gets us -I. I to the eighth is 1. I to the fourth times I to the fourth is 1. See a pattern there? I -1, -I1. But it's not a pattern you have to memorize. It's a pattern you can figure out. And then if we ask for something like I to the 37th, let's see, all the multiples of 4 are equal to 1. All the multiples of 4 are equal to 1. So how could I split this up? Like, what would be a good number to go there? I'd really like a multiple of 4 to go there, because a multiple of 4 means that'll be 1.
Oh, it's 1.
Well, what number should I put there, though?
32.
32 is a multiple of 4, but that would leave 32 and 5. So let's go 36. So you want the biggest multiple of 4 that you can get to. So I would do 36. 32 would work, but it might be a little harder to deal with. So if that's 36, then what does this one have to be? What does this exponent have to be? 1, because 36 plus 1 is 37. And when we pick I to the 36, that gets us 1. So that answer is just I. Now, there's multiple ways to do that. To me, this is the easiest way. Just get the highest multiple of 4 you can use, and then whatever left over is basically your answer. You can do more complicated things where you divide by 4 and use the remainder, but that's maybe more work than you want to do. You can also, this is my favorite way, is to count up every single time. Like if I need to get to 37, 1, 2, 3, 4, 5, 6, 7, 8, but then it just keeps counting over, 9, 10, 11, 12, 13, 14, 15, 16, and you just count until you hit 37, and 37 would land on I. It's not the quickest way to go, but it might be the safest way to go if you forgot. What about something crazy like I to the 502? So I need a multiple of 4 that's a little less than 502. It's like, what are the multiples of 4 that are that high? Is 100 a multiple of 4? So that means 200 is a multiple of 4, and 300 is a multiple of 4, and 500 is a multiple of 4. And so why did I pick? Let me start picking on people. Madison, why did I want a multiple of 4 right there? What does that do for me? Positive 1, yeah. Multiple of 4 makes this equal to positive 1. And then I squared, we know, is negative 1. So all of that is just negative 1. Let's give you to try a couple. I to the 72, I to the 97th, I to the 1003. We like throwing the big numbers up there. Click on this. If not, then let's divide by 4 and use the remainder. So let's see. 4 goes into 72 once, bring down 4, 32, 18. So what's my remainder? 0. My remainder is 0. So that means that I to the 72 is the same thing as I to the 0. Whatever your remainder is, you can use as the power. And anything to the 0 is 1. Or 72 is a multiple of 4, so you're going to land at 1. Let's do 97 divided by 4. 2 times 4 is 8. 4 times 4 is 16. What's my remainder? 1. So that means I to the 97 is the same thing as I to the first, which would just be I. Mm-hmm. So another way to write this one would be, this is the same thing as I to the 72 times I to the 0. But I know I to the 72 is equal to 1 because it's a multiple of 4. That's the other way to do it. 96 is a multiple of 4. So once I get to 96, I'm at 1, and I just need one more I. So if you know the multiples of 4 quickly, that's probably an easier way to go. If you don't know the multiples of 4 that quickly, then maybe you do the division with the remainder. Maybe you can kind of combine. Like if I divide 1,003 by 4, do you know what the remainder is going to be? The answer would be 250. What would the remainder be? 3. There'd be 3 left over. You'd have 250 groups and 3 left over. So this is the same thing as I cubed, which then we got to think about what I cubed is, but that's I squared times I, so that's negative I. Okay, yeah, we need to do some more then, because that was, let's go with 86 and 45. Divide by 4, use the remainder.
How many 4s fit in there and what's left?
And then the important question is not how many 4s fit, but the important question is what's left. Do you only use the remainder? Because I to the 21st, 21 I to the 4th is going to be 1, because I to the 4th is 1. So you only need the remainder. Now, again, you can sometimes do this without going through this. Like, what's 45 divided by 4? What's the remainder? How many extras are there? Yeah, there's just one. 44 would be an even multiple of 4. So some of you will start to skip over the division step and just know that, well, that remainder would be 1. If I did 45 divided by 4, I'd have 1 left over. Some of you can't do it in your head. You want to multiply it out. That's okay. Yep, sure enough, we get a remainder of 1. So I to the first is I. Okay, better on that? So divide by 4, use the remainder. But you would still have to know, or be able to figure out these first 4. But the first 2 you already know, and you can figure out the second 2, hopefully fairly easily. Okay, back to the warm-up page. Negative 5i to the 7th minus 6i to the 109. Let's see, what's I to the 7th going to be? Let's simplify these first. Or what is it the same thing as? How many would be left over if I divide by 4? Be the same as I cubed. And I cubed is equal to negative 1. No, not negative 1. I squared is negative 1, so this is negative I. So negative 5 times negative I, that would be 5i for that first piece. I to the 109. Do you know how many would be left over? What the remainder would be if we divided by 4? 1. Good, because 100 is a multiple of 4, which means 104 is a multiple of 4, which means 108 is a multiple of 4. So we'd have 1 left over. So I to the 109th is the same thing as just I. And 5i minus 6i would be negative I. Okay, that's it for the crazy powers of I. But there is definitely a test question with a crazy power of I on it, so make sure you understand that remainder stuff. Okay, back to the old stuff. Root negative 10 times root negative 6. What do I need to do with that negative? How do I handle that?
As an I.
Take it out as an I. Take your eyes out. So I root 10 times I root 6. Let's see, I times I is I squared. This is where people start skipping steps. What's I squared equal to? Negative 1. So, do you want to skip straight to negative 1, or do you want to write the I squared? Up to you. So I squared is negative 1. And then 60. Feels like I could break apart 60 into something that has a square root and something that doesn't.
4.
Yeah, 4 and 15. So negative 2 root 15. Yeah. Right. Why don't you try number 3? Let's just distribute and collect like terms. Number 3, that's an easy one. Let's take 6i and distribute that to 5 minus 2i. So 30i. What's the second term going to be? I'm trying to encourage you to skip steps, which is probably not smart for a math teacher to do. But what's 6i times negative 2i going to end up being? Positive 12. So it'd be minus 12i squared, which is plus 12. Hayden, do you remember how to fix number 6?
You have to times by 7.
Let's back up a second. So that would work, but there's an easier way to go. What's wrong with this? Why do I say we need to fix it? What needs to be fixed? The I in the bottom. So what do I need to do to fix the I in the bottom?
You just change it to...
You were closer the first time. You said multiply top and bottom by?
So just split times by I.
Just by I. The 7's okay. I don't need to worry about the 7, but I do need to fix that I down there. So that would be 2I over negative 7. Right? Show it if you need to, but 7I squared is just negative 7. And it doesn't matter where the negative goes. You could leave it in the bottom, or you could put it in the top. You could put it out front. Hayden, if you did multiply by 7I, it's fine. You would just end up with 14I over 49, and you'd have to reduce. The 7s would eventually go away. So, yeah, only fix what needs to be fixed.
So we got all the I's on you.
I do. All the I jokes. It's all fun and games till somebody loses an eye. Ava, you started it then. Ava, how do I fix this one? This one's a little bit different. So just multiplying by I is not going to work, right? Because it would fix the 2I but mess up the 4. So I'm glad you did not say that. Does that jog your memory?
I remember it, but I don't remember what I'm supposed to do.
Okay. I mean, I don't care if you know it.
I need to change the sign.
You change the sign. Yep. What's the rest of it?
Isn't that called keep it, change it, flip it?
That's not keep it, change it, flip it. I don't care if you know what it's called.
Is it HSA or whatever?
No, that's HSA is complete the square.
Oh, never mind.
It's called a conjugate.
Oh.
And Ava's right. All you have to do is change the sign. So the rest of that stays the same. So that's still 4 and 2I. It's just 4 minus 2I on the top and bottom. Let's FOIL the bottom first. Do you remember what happens when we multiply by the conjugate? It's why we multiply by the conjugate. It's supposed to fix the i's. The I stuff should all go away. So let's FOIL the bottom first and make sure that happened, because then we'll feel good about being on the right track here. So 16 minus 8I plus 8I. Then how about that? The L of FOIL. 2I times negative 2I is negative 4I squared, which is the same thing as plus 4. So sure enough, our i's went away, which means we probably did that correctly. Now we need to clean up the top, or FOIL the top. 24 minus 12I minus 4I. And then that last term, negative I times negative 2I. What's that going to turn into? Good, negative 2. It would turn into positive 2I squared, which is negative 2. So 22 minus 16I. Is that my final answer?
No.
What can I do?
Simplify.
Simplify by
2.
2. Right? The 22. I can't simplify that one by 4. The other 2 will go by 4, but it has to divide into everybody. If we really want to show our steps, we could factor out a 2. This helps with the people that struggle with canceling factors, not terms. You factor out the 2, then it's clear that the 2 will cancel. 11 minus 4i over 10. Most of you are not going to show that step. You're going to jump straight to there because you just divide everybody by 2, which is fine. What's that? Uh-oh, what'd I do? It would be 8i. Thank you. Say that's why I should show my work, but I still messed it up. Oh yeah, we're good. We'll finish this week. Yeah, these are all test inspired. This page is test inspired stuff. As we're working through these, I did the key last night, by the way, so it's fresh in my mind, and I keep thinking, oh yeah, that's on the test, that's on the test, that's on the test. So this is definitely a good review warm-up page here. What do you want to do first on number 8? It says solve using any method. What do you want to do first on number 8? Minus 26? I think I'd rather minus 10, because I think I can get the x squared by itself. So I'm going to use the square root method on this one, since there's only an x squared. I can get the x squared by itself and then square root both sides. So let's move the 10 over. What do you want to do next? I like that. Times by 3 over 1. I would go even one step further. Like 3 over 1 would fix the fraction part. But while we're fixing things, I would say let's multiply by negative 3 over 1. That way we fix the sign as well. So you could do that in 2 separate steps, and I like the 3 over 1 because that will fix the fractions. But again, while we're fixing things, we may as well fix the negative sign as well. So x squared equals negative 48. Emery, what do you want to do next?
You get the square root. Wait.
No, that's right.
Okay.
To get x by itself, we would square root both sides. Now, there's a lot of stuff left on the right-hand side to think about. I'd say there's at least 3 things to think about. See if Ben, George, and Scarlett can come up with those 3 things. So, Ben, tell me one thing I need to...
Add the I to our side.
Okay. The negative would come out as an I. I like that. So I square root 48. That's one thing we have to fix. George, what else needs to be done? Okay, and how could I square root the 48? Well, I mean, yes and no, right? Like 6 times 8 is 48,
Yeah.
but that doesn't help us because neither of those are perfect squares.
4 and 12.
4 and 12 is better. 4 times 12 is 48.
16 and 3.
16 and 3. Also, it's kind of right there, but so 16 and 3. So that's 4i root 3. And you guys have left Scarlett with the trickiest thing and probably the most often forgotten thing. Well, I guess they did the hard part, but they forgot the tricky part. Scarlett, you know what's missing from this answer? It's the most frequently missed part of this answer. It's not a hard part, but people forget about it. What am I missing? Uh-oh, nobody knows? Wait, somebody said it, I think. The plus or minus. When you put the square roots on, you've got to remember to put the plus or minus. And so I really should have put it on right back there when I first did this, but I intentionally left it off to be able to pick on somebody about that. When you square root both sides, you got to include the plus or minus. Okay, solve by factoring. Right, any questions on number 8? I don't want to blow through that if we're still got questions there. Layla, if I want to solve number 9 by factoring, what should I do first? That would work. If you go that way, I'm going to call on you a second time. Layla said move the 2x squared over. What would you need to do next, Layla? Isn't that what you said to do? Move the 2x squared over? Okay. So take out the negative. So what's another way to do exactly what Layla said? She did it in 2 steps. I guess the other way would also be 2 things. What?
Move the 7x and the 3 over.
Right, move the 7x and the 3 over. Either way, you're going to end up with 2x squared minus 7x plus 3. So it's kind of up to the person. Like Layla wanted to move only one thing over and then fix the negative. That's fine. Somebody else, like Ava, might have wanted to move the 7x and the 3 over. That way the 2x squared is positive. Either way, you land there. Now for the fun parts. It's got to be 2x and x. Reaching for a pencil in case I make a mistake. Well, I guess the good news is my only options are 1 and 3. So it's just a matter of where the 1 and the 3 go. So if I put the 3 there and the 1 there, the signs have to be the same, but they both need to be negative. I can put those in pen because that's got to be negative, negative. Did I guess right with the 3 and the 1? No, I did not. But that's okay. We try again. Is that going to work? Yeah, because the double smiley face thing, now I've got -6, -1, make -7. Am I done with that problem? I factored it. What do I do with my factors? Good. Set both the factors equal to 0. This is the step that some of you don't show, which is okay. Because it's easy from there. So move the 1 over, divide by 2. Move the 3 over. So my 2 answers. If I had extra time and I wanted to really make sure I was going to make 100 on this test, what could I do with those answers? I could plug them back in and make sure they work. 1/2 might be annoying because squaring it, but I could plug it in. 3 would be easier to check. Number 10. Still solving by factoring. Jordan, what do you want to do first on number 10? On number 10?
Number 10.
Yeah, oh, you were looking at 11. Yeah, move the 15x over. We want it equal to 0. Kinley, this one's a little different than the last one. Do you know how we would factor this one?
Well, first we would factor out 5.
Yes. Well, yes and no. What else could we factor out? I like taking out the 5.
5x.
But we could take out a 5 and an x. Elisa, what would that leave if we take out a 5 and an x?
That would be 5x minus, x minus.
Yeah. And then Max, once it's factored, what do we do with our factors? It's the step that people don't show, and then they get messed up on a problem like this. What did we do with our factors right here? Set them both equal to 0. So 5x equals 0, and x minus 3 equals 0. So I'll take the easy one, x equals 3. But Nia, what about that other one? If 5x equals 0, what does x equal? 0. Another one to check, although that would be an easy one to check. 0 definitely works, because 0 equals 0. 3, 5 times 9 is 45, 15 times 3 is 45, so that's an easy one to check. Okay, let's do one more and then we'll be done for today. Solve by completing the square. Jordan gave us the first step already. He said move the 6x over. I'm a little pressed for space, so what else should I do? What else should I move around here? The 33. Let's get the 33 out of the way. So I'm going to subtract it to the other side. And then, Corinna, you listed the steps earlier for a different problem.
Oh, HSA.
HSA. HSA. Ocean, what does HSA stand for? Yeah. Right. It's no use memorizing HSA if you don't know what they mean. So half square add. When we say half, Samantha, half of what? Perfect. Well, almost perfect. Just half of negative 6. Leave the x alone. Half of negative 6 is negative 3. Angelina, what do I do with that negative 3? Square it. That gets me 9. Eli, what do I do with the 9? Eli, what do I do with the 9? Add it to both sides. So plus 9, plus 9. Okay, that's the half the square added part. There's still more to go. I need to factor the left, but as always, the factor is b over 2, so it's not a difficult factoring problem. We may get through everybody today. Fernando, what do you want to do next?
What I'm thinking is you foil the x minus 3.
If I foil that x minus 3, I'm going to get back to this.
We're going to get back to that.
So I don't really want to do that. I mean, it wouldn't be like wrong mathematically. It just wouldn't be getting me closer to the answer. How could I undo that square? Let's square root both sides. And let's catch the problem here that we almost forgot about last time. When I put the square roots on,
Plus minus.
the plus or minus. And then I've got some work to do. I need an I out of there. 32. Did I mess something up? Some of you are looking at me like I'm... Negative 33 plus 9. That would be negative 24. Sure would. Speak up sooner. Next time. Alright, how can I split up 24? 6 and 4. So that would be... Oh, this is going to look funny, but 2 square root of 6. It looks funny because the I is in front. That just looks funny. Move the 3 over. So 3 plus or minus 2I root 6. Or if you want the I at the end, that's okay. Just make sure it's clearly not under the radical. Okay, so the only new thing today was that weird powers of I business that we started with. Everything else was review. Again, I'd say today's assignment is the odds and tomorrow is the evens, but you split it up however you want to. Tomorrow we'll do some more warm-ups. I'll work some of the review, and hopefully then you're all caught up and ready to test on block day. Probably the last thing, we didn't get to this, but for the vertex, x equals negative b over 2a. Does that sound familiar? And then you go from there. But we'll do some of those tomorrow.